Hi, in this lesson we're going to be looking at ways to display bivariate data, so data with two variables. So here we're going to be looking at the relationship between the two variables. Now the kind of display we choose is going to depend on the types of variables we're looking at. We could be looking at two quantitative variables, two qualitative, or one of each. So let's start with two quantitative variables. So this is a data set that I made up, but I based it on an old episode of WKRP where you've got two people who are drinking different amounts of alcohol, drinking increasing amounts of alcohol, and checking their reaction time according to a machine. So here's the data as I made it up. And what we want to do is just a scatter plot. And let me show you how we do that in SPSS. So here's our data. We're just going to go to Graphs, Legacy Dialogues, Scatter Dot. All right, so Graphs, Legacy Dialogues, Scatter Dot. And we're going to pick Simple Scatter. And if you're just looking at strictly the relationship between two variables, it doesn't really matter which one goes on the x-axis and which one goes on the y-axis. Typically, though, whichever one is doing the predicting, we put on the x-axis, and the one that's being predicted, we put on the y-axis. So in this one, we think that number of beers is going to have an impact on reaction time. So we're going to use number of beers for the x-axis and reaction time for the y. So we'll click OK. And we can go look at our scatter plot. So the scatter plot here, you can see the dots are more or less in a straight line. They're not perfect, and they're not going to be. And there's nothing wrong with that. But what we can see is that it does look like there is a relationship between beers and reaction time. It looks like I said, it's linear as opposed to something that goes up and then comes back down, or something like that. It's a positive relationship, meaning that as one variable goes up, so does the other one. So if you're reading it from left to right, it's increasing. And it seems to be a pretty tight relationship too. The variables, the data points tend to be highly clustered around that line. So that's what you can find out from the scatter plot. Qualitative variables. So if both of our variables are qualitative, there's a couple things we could do to display the data. First of all, here's our example where we've got a combination of variables, gender, and which candidate of two candidates the person voted for. So there's two things we're going to look at here. One is a cross-tabulation. So to get that, we're going to analyze, descriptive statistics, crosstabs. And we're going to pick one variable for rows and the other one for columns. It doesn't really matter which one. And we'll click OK. And this, what they're showing us here, is the cross-tabulation. It tells us, and I think we can see it a little better over here maybe. It just gives us the number of people in the data set who were female and voted for candidate A, female and voted for candidate B, male and voted for candidate A, and male and voted for candidate B. So that's kind of all that tells you. But we can add percentages. Now, the thing is, there are 3 ways we can put the percentages on there. Let's start with the easiest one. So we go back to Analyze Descriptive Statistics crosstabs. And we're going to click on Cells. So let's first click on Total. This is the easiest one. And we'll click Continue. And we'll click OK. Here we see this 24%, 28%, 32, and 16. This 24% here means that out of everybody, out of all of the 25 people in the data set, 24% were females and voted for candidate A. 28% were females and voted for candidate B. 32% were males and voted for candidate A, and 16% were males and voted for candidate B. If you add up these 4 percentages, they add up to be 100. Okay? So now let's change the percentage. Going back to crosstabs, and we're going back to cells. And we're going to turn off the total percentages and turn on the row percentages. And let's see what happens. The row percentages give us out of that row what percentage voted for each candidate. So here where you see 100%, this means of all females, what percent voted for candidate A and what percent voted for candidate B. Down here, out of all males, so out of, and you can see that it's that row because there's the 100%. 2/3, 66.7% voted for candidate A, and 33.3% voted for candidate B. This is useful if you're trying to see how females voted versus males. So if you're interested in of all females, how did they vote, versus all males, how did they vote, this is what you do. Okay, so you'd look at this table. All right, so I realize this is a little confusing. So again, here's what we're looking at. Where it says 100%, that means out of this row, meaning of all females, how did they vote? So of all females, 46.2% voted for candidate A and 53.8% voted for candidate B. Down here we see 100% here. So for all males, 66.7% voted for candidate A and 33.3% voted for candidate B. Okay, so that's the row totals. Now let's look at the final one, which is column totals, and that one is just the reverse. So if we go back to cells, we're going to change this to column percentages. Click Continue and click OK. And now you see that 100% is down here. So this means of everybody who voted for candidate A, 42.9% were female and 57.1% were male. Of all the people who voted for candidate B, 63.6% were female and 36.4% were male. This is something that's going to be useful to you if you want to know within each candidate, how did people vote? So if you're interested in, of all the people who voted for candidate A, what was the breakdown of gender? Versus of all the people who voted for candidate B, what was the breakdown of gender? So that's crosstabs. If you're interested in looking at a bar graph equivalent to these, here's what you're going to do. You're going to look at, these are clustered bar graphs. And let me show you how to do those. That's just under Graphs, Legacy Dialogues, Bar, and we're going to pick Clustered. And let's first put category axis as gender and define clusters by candidate. And we'll click OK. And so this tells us of all the females, how did they vote? So of all the females, it looks like more of them voted for candidate B than candidate A, whereas of all the males, more of them voted for candidate A than candidate B. Now let's switch those. So we're going back to Graphs, Legacy Dialogues, just like we did before. But this time we're going to put candidate as the category axis and gender as defined clusters by. So click OK. And now that tells us of all the people who voted for candidate A, more of them were males than females, and of all the people who voted for candidate B, more were females than males. So it's a subtle difference, but it does make a difference. So, like I said, this one on the left is the better choice if you're comparing the choice of candidate within gender. And on your homework, I will specify which one of those I want. I'll specify something along the lines of choose the way that allows you to compare choice of candidate within gender. So you would know that within gender, I'm looking for which candidate did they vote for. Okay? Or a slightly different example, but you get the idea. All right, so that's qualitative with qualitative. One more. Now, if we've got quantitative and qualitative together, this is what it would look like. So here we've got an example where we've got people taking either a placebo or a medication for migraines, and they're going to rate the severity of their symptoms. So this one is our qualitative variable, and then the severity is our quantitative. Basically what we're doing here, you could consider this as looking at the relationship between treatment and severity. We could also think of it, and it's completely equivalent, to comparing the severity of placebo to the severity for the medication. So we have two groups here. We've got the placebo and the medication, and we want to compare them. So if we go to our SPSS file, I think the easiest way to do this is to go to Analyze, Descriptive Statistics, Explore. You want to put the quantitative variable. You have to be very careful here because people tend to get these backwards. The quantitative variable is the dependent. The qualitative one, the grouping variable, goes under factor list. So make sure that you're putting your quantitative variable, your numeric variable, under dependent list. And here I'm just going to turn off, under plots, I'm going to turn off the stem and leaf because I don't need that. And I actually don't even want the statistics, I only want the plots. So if we click OK, this gives us a side-by-side box plot. And we're going to talk next week a little more about the details of what's in a box plot, but it kind of just shows where the data is laid out. This box represents the middle 50% of the data, and these bars basically show the max and the min. So you can see here that people who took the placebo had worse symptoms than people who took the medication, which means it does look like the medication is helping because it's causing a lower severity of symptoms. And if you remember, we can use the word cause because if you've got random assignment and some people are taking a placebo, then you do have an experiment, which means if one group is different from the other, that means we've got cause and effect. So you can see here that there is a difference between the groups. The placebo has more severe symptoms. All right, so that's it for this lesson, and let me know if you have any questions.